Hey, this is Patrick Hall of Aalborg University, Copenhagen, here to present my first hint-in for procedural programming, a runner game. First, I'll demonstrate the game, and then I'll go through its code. As you can see, we can move left and right in this game. We can jump. Each time we hit a TNT box, we lose health, as seen in the upper left corner. If we die, the game resets. We can also collect coins, which will then increase the counter of coins, seen also up in the top left. And that's pretty much it. So, in the code, we have three scripts: the game master script, main camera, and player script. I'll go through them one by one. Okay, first off, it is important to note that this function doesn't do anything. I'm keeping it here so that I can use it later. Sorry to confuse you guys. Next, we have the update function. Now here, I'm saying that if lives go below 1, meaning 0, I'll end up having no lives, and the application will restart. As you saw, when I reached no health, hitting too many TNT boxes, the game simply reset. We have the coin counter down here saying that we want a new style, GUI, graphical user interface style, and we set this new style to be a new font, making it possible for me out in the game to set a font that I can use for a text field later on. Then we set the color of the font, here meaning is it between 1 and 0 as to how many percentages of color we have, red, green, blue. We have here like 100% red and 80% green, meaning that it's orange, I think it was. Then we have graphical user interface text field, setting up where the text should be and saying that it should say coins, space, and then count the coins that we have collected. We also have, and the font size, sorry, forgot that one. We have the positioning and the removal of the hearts that you saw, representing the health of the player. And we set in the lives here, setting the counter, and we have the draw texture going down to setting up our heart texture, which I found at random, and its size. And we also have this neat thing saying scale to fit, so that he will have the same, spacing in between them, making it look neat and nice. And let's take a look at main camera, also fairly simple. We have our transform target, setting this up meaning that we have the camera that follows the player in a steady pace. Here we have our vector lerp. Lerp is meant as a special vector that then will, in case the object that it's following increases or decreases in speed, will smoothly transition to following it and then stay behind it instead of being abruptly moving forwards and backwards toward the player. It's simply a thing to make things more smooth. You might know it from Assassin's Creed actually. They use it a lot there, I think. And then we have our transfer position. Now we have our X position, transfer position, and then for our Y position we actually set up an entirely new vector within the vector we just made, saying that we want to be on top of, or actually in the center of, the player position, -5 on the Z axis, setting us up right behind the player. And then as our final actual Z coordinate for this overall lerp vector, we have 0.5. Final script is the one that I cramped the most of my code into. Now, we'll start out by looking at, didn't use that. Collision registration. Now, I made this void function for on hit collision enter. Now, I'm going to call my collision hit. And so I'm going to say that in the instant, going to get back to that one. Player collides with a fast or slow moving TNT box, health is lost. As you can see here, if the hit collision that I set up here, dot game object and name, meaning that if this function of the script win, meaning the player script, which is tagged to that, hits a cube or cube 2, as is the fast and slow cube, or vice versa, I think. I have 2 types of cubes. Are struck, then the lives will go down by 1 and it will destroy the object that it hit. So basically the TNT box won't stay there after it's been struck. It will be registered as health low and it will remove it. And this is pretty much the same overall structure that I used for these next four pieces of coding. We have this, that if it's a rectangle, in this case, I know I'm not very creative with the naming, but it's the TNT box barricade that you have to jump or else you're going to collide with something. Because I had to use the jump function for something, it's also life lost, and I'll make sure to remove one of the TNT boxes that is struck. We have the coin colliding, which is basically the same again. We have the coin counter here, saying they'll be counted up plus plus. And lastly, we have, if you hit the final piece of the highway, the application should quit. Now, had I succeeded in making this work, I would have been a little more elaborate on that, and maybe set up some kind of game over text and showing how many coins were collected or something. Now, what's important to remember about these things here is that we're saying coins and we're talking about lives. Now, the coins and lives are not in this script, they're in the game master script, as seen here. Where is it? Here they're declared. Here and here. This means that we'll somehow have to get a hang of them from this script within the player script. As such, we're using this instance linking so that we can get so basically calling to this script saying that we need something from it and we need to alter it. So I set it up like this. Now it's game. It's looking for the game object game master, which is set up out here, and then we have the find game master. So it becomes this, and then we can find it. We have the game master script and game master script set here. Game master get components, game script, meaning that then with this we can say game master script in order to get a hold of this script that I made up here. I'm repeating myself. Okay. Finally, we have a final update function saying that player movements, and we have the rigid body, which is of course the way of setting up a physically representable item in Unity. I'm lacking words here. Making a realistic structure of anything in Unity. And then setting its velocity so we can control it. Now we have a new vector so that we say input, get axis, horizontal, We can set the left and right controls of... Am I getting this backwards? Nope, still right on track. We have the left and right controls here. Then we have the actual gravitational pull of the overall map, saying that if we jump, it should move back down at a certain speed. And then we lastly have the constant forward motion of 14 units. Basically here I can set up the speed of the game, which I did in order to make it a bit more interesting. And then lastly we have the jumping, saying that if key down is space, we set that key down button press to be rigid body add force, and then we basically give it a force that will push it up against this gravitational pull. In this case I set it quite high because I wanted the jump to be sudden and forceful, but also I didn't want it to hang up in the air. So I increased the gravitational pull slightly, and at the same time also gave the player more force. So it'll jump up more abruptly and fall down quickly. I believe that is all I have to demonstrate for this time. Boom, boom. Yep, looks about it. So thanks for listening, and I'll see what they'll throw at me next.